Hello and welcome to Makeup Project. Makeup Mastery Project for Unit 5 Mastery Project. So for our first question, well, our only question really, we have a block right here, block M. It's falling down. It's about to hit block Y. So after they collide, both blocks have a final velocity. So the first question is. Say a basic physics principle, law, equations, or equations that students can use to determine the relationship between the release of height x and the speed of which the two systems collide after the blocks collide and stick together. So, what does that mean? Basically, that just means like identify everything that we're going to use. So we're going to use two things. First of all, we're going to use conservation of energy. So let's write that down so we don't forget. Conservation of energy, and we're also going to use the thing that we've been using all along, momentum, conservation of momentum. Alright, so that should be the answer for the second one's actually asking you for what equations are you going to use. Okay, so we're going to use, here, let's write this. AII. What equation do we need? Conservation of energy. What is conservation of energy? MEI is equal to MEF. Alright, so since we have potential, and then the potential turns into kinetic. So potential would be mgh. As it falls down, it goes to kinetic, is equal to 1/2 mv squared. And then a little down here, we go to pi is equal to pf, because it's a collision, right? So why do we need energy? Basically, all we really need energy for is to derive v, because like you said, Mr. McClure, we cannot derive v. We cannot just say v is equal to square root of 2gh. We have to derive it. So we just simplify it down. So you multiply this, 2mgh is equal to mv squared. Maths cancel out, so you're left with 2gh is equal to v squared, square root. So square root of 2gh is equal to v. All right. So now we have momentum right here, and since we know that this is gonna be falling, this is mass x mv o, because there's no initial velocity, and we know there's no initial velocity for this one, so plus mv o my vo is equal to mx v final plus my v final. All right, so we know that since this is not moving, like, we don't really need to look at this. We can factor out the v, so we're left with mx vo is equal to vf mx plus my, because after they collide they stick together, that's why it's a plus. And from there, it's just solving, really. This doesn't really matter since there's no... Wait, no, it does matter, sorry. It does matter. VO. So we just plug this in here. VF would just be equal to... mx vo divided by mx plus my, right? So how do we get this initial velocity? Well, this initial velocity, since it's an object that's like falling, that has no other force acting upon it, we can just say that it's a v. So we can just further simplify. So v final is equal to mass of x square root of 2gh divided by, parentheses, divided by mx plus my. So that's our final equation that we are going to use. 1 second while I write the next part. And so from here we have our quantity. This is our graph that we're going to be using. So what we're going to be finding is the quantity. We have mass. We're going to try to find mass because it's the only things that are variables. The only variables we really need to know are mass of x and the height to find the final velocity. So all we really need is equipment, a scale. I'm going to be measuring in what's this called? We're going to be measuring kilograms, but the symbol for that is mass. kg scale, electronic scale, any type of scale, doesn't really matter. Meter stick. Oops, wrong one. I apologize. Mass is not M. Mass is kg. I apologize. And from there, what's the last question? Part C. Oh, describe procedure. So yeah, like I was saying, all you really need to do is first off measure how high it's gonna be. So measure the height. So once you find the height, all you really need to do is find the mass and then just plug into the formula. So for the final part of our little mastery project over here, we have these set of data that we are given. So our first one is the actual speed of the block W, so block X, after collision with block Y. So basically, here, let me draw it out. A block comes out here, hits it. This is the velocity after it hits it, so after the moment of impact as they're both going through. As you can see, at some point it goes back in the negative direction, something like that. But the question thing is asking, why is it that when you add them up, they don't add up to the total, they don't add up to the predicted velocity? Well, that's because they're not perfectly elastic. And that's kind of the answer to the question. Well, they're not perfectly elastic. They do stick together after. It could be a possible thing. It could be because of friction. It could be because of wind. But what's most likely the case is that they just stick together after, and then they go their separate ways. It would honestly be the most case with this one. This one would be the most elastic one because it goes and then it separates a little as this one goes. But really, we can notice that this one just kind of they just stay together. And that's the concept that College Board wants you to understand. So yeah, that makes up all my missing assignment. Thank you so much for listening.